statistics, we are doing another correlation practice. The one we did on Friday sounded a little confusing, so we're going to do another one in class today. Those of you who are in class are doing data that we're developing in class, and those of you who are at home today are going to use this data right here, which is a table of height and shoe sizes of 6 randomly selected men. Okay, so I've included the correlation formula. You'll find that in your notes. And we're going to start by doing the z-score for the x's, which is this part right there. That's the z-score for the x's. Okay, so I need to calculate what my x bar is and what my s of x is. Okay, I'm going to say that x is the height, because I would assume that height influences shoe size. So again, I'm using height for my x's, and I plugged in my x's to Stapplet into the one quantitative variable single group option. So I got a mean of 71.6 and a standard deviation of 4.7. Okay. You could do the same thing for your y coordinate. You get your y bar and your standard deviation of y. All right, once you have the mean and the standard deviation, then you're going to standardize it. Remember, that's this part where you do x minus x bar divided by the standard deviation. So for 67, that's the first one. We do 70 minus 71.6 divided by 4.7. Okay, so I've got a z-score of negative 0.34. And then you're going to do that for 70. You're going to do 70. Oh, that was 70. Oops. Okay, I need to do that for 67. 67 minus 71.6 divided by 4.7. So the z-score for 67 was actually negative 0.98. And I would go to hundreds on those. Okay, so you're going to do the z-score for all the x's, 73, 75, 78, 66. And then you repeat that process and do your z-score for your y. So we're going to have a y column and a z-score of y columns. Okay, now I've kept these in rows on purpose. So this row, I guess maybe a different color, this row here was all from this person here. And this row here was all from that person there. So now we're going to multiply the z-score column. So you're going to take negative 0.98 times whatever you got for the z-score of y, multiply those two together. That's what's happening right here. So multiply the z-score from the x times the z-score for the y, and you're going to do that 1, 2, 3, 4, 5, 6 times, one for each coordinate. And I highly suggest you write them down. If I was smart, I would have left enough room so I could do another column over on the right, but I ran out of page. After you multiply those, you add them. So you're going to add these 6 multiples of the z-scores. Zx times zy. Zx times zy. You're going to add them up. At that point, you have finished the summation part of the correlation coefficient. And then you multiply that whole, after you sum them all up, multiply that by 1 over 5, because it's n minus 1, 6 minus 1. 1 over 5 times that summation. Okay, I want you to finish that up, and we'll talk about it in the Google Meet today.